Hello students, and welcome to the lecture on cellular telephone systems. After the lecture, we will be able to learn the following objectives. Understand cellular telephone systems. Explain first and second generation cellular telephones. Understand narrowband advanced mobile phone system. Discuss interim standard. Explain the global system for mobile communications. Understand personal communication satellite system. Let's start with a brief introduction to cellular telephone systems. Mobile telephone service, or MTS, is a type of service where mobile radio telephones connect people to the public switched telephone system, or PSTN, to other mobile telephones or to other communication systems, such as to the Internet. Cellular Personal Communication Service, or PCS, and third-generation 3G mobile radio systems are all cellular wireless communication networks that provide for voice and data communications throughout a wide geographic area. The MSC contains communication controllers that adapt signals from base stations into a form that can be connected or switched between other base stations or to lines that connect to the public telephone network. The switching system is connected to databases that contain active customers active in its system. Let's now take a look at cellular telephone systems. The first mobile system was devised in the US by AT&T and mandated for the whole country by the FCC. As a result, the entire US had a single analog system, and a mobile phone purchased in California also worked in New York. Wireless telephones come in two basic varieties: cordless phones and mobile phones, sometimes called cell phones. Cordless phones are devices consisting of a base station and a handset sold as a set for use within the home. These are never used for networking. Europe learned from its mistake, and when digital came around, the government-run PTTs got together and standardized on a single system, GSM, so any European mobile phone will work anywhere in Europe. A second area where the US and Europe differed is in the matter of phone numbers. In the US, mobile phones are mixed in with regular or fixed telephones. A third issue that has had a large impact on adoption is the widespread use of prepaid mobile phones in Europe, up to 75% in some areas. These can be purchased in many stores with no more formality than buying a radio. One pays and goes.
Unlike ordinary phones, which connect to the network by wire, a cellular telephone connects with the network by radio waves. A cellular telephone is actually a radio transmitter and receiver. These phones work with a network of low-powered radio antennas and transmitters. Each station serves a geographical area called a cell. When an antenna receives radio signals from a cellular telephone, it sends them to a switching office, which in turn sends them by cable into the ordinary telephone network. The call is then routed to its destination. When a person in a moving car uses a cellular telephone, the antenna in the nearest cell handles the radio signals. As the car moves, the signals pass to the next cell without interrupting the call.
Let's now have a look at cellular telephony. Cellular telephony is designed to provide communications between two moving units, called mobile stations, or MSs, or between one mobile unit and one stationary unit, often called a land unit. To make this tracking possible, each cellular service area is divided into small regions called cells. Each cell contains an antenna and is controlled by a solar or AC-powered network station called the base station, or BS. Each base station in turn is controlled by a switching office called a mobile switching center, or MSC. Cell size is not fixed and can be increased or decreased depending on the population of the area. The typical radius of a cell is 1 to 12 miles. High-density areas require more geographically smaller cells to meet traffic demands than do low-density areas. However, the set of frequencies available is limited, and frequencies need to be reused. A frequency reuse pattern is a configuration of n cells, n being the reuse factor, in which each cell uses a unique set of frequencies. When the pattern is repeated, the frequencies can be reused. Transmitting. To place a call from a mobile station, the caller enters a code of 7 or 10 digits, a phone number, and presses the send button. The mobile station then scans the band, seeking a setup channel with a strong signal, and sends the data, the phone number, to the closest base station using that channel. The base station relays the data to the MSC. The MSC sends the data on to the telephone central office. Receiving. When a mobile phone is called, the telephone central office sends the number to the MSC. The MSC searches for the location of the mobile station by sending query signals to each cell in a process called paging. Once the mobile station is found, the MSC transmits a ringing signal, and when the mobile station answers, assigns a voice channel to the call, allowing voice communication to begin. Handoff. Hard handoff early systems used a hard handoff. In a hard handoff, a mobile station only communicates with one base station. When the MS moves from one cell to another, communication must first be broken with the previous base station before communication can be established with the new one. This may create a rough transition. Roaming. Roaming means in principle that a user can have access to communication or can be reached where there is coverage. A service provider usually has limited coverage. Neighboring service providers can provide extended coverage through a roaming contract. The situation is similar to snail mail between countries. Let's now have a look at first-generation analog cellular telephones. To talk, the user had to push a button that enabled the transmitter and disabled the receiver. Such systems, known as push-to-talk systems, were installed in several cities beginning in the late 1950s. CB radio, taxis, and police cars on television programs often use this technology. In the 1960s, IMTS, Improved Mobile Telephone System, was installed. It too used a high-powered 200-watt transmitter on top of a hill, but now had two frequencies, one for sending and one for receiving, so the push-to-talk button was no longer needed. IMTS supported 23 channels spread out from 150 MHz to 450 MHz. Due to the small number of channels, users often had to wait a long time before getting a dial tone. Also, due to the large power of the hilltop transmitter, adjacent systems had to be several hundred kilometers apart to avoid interference. Advanced mobile phone system. All that changed with AMPS, Advanced Mobile Phone System, invented by Bell Labs and first installed in the United States in 1982. It was also used in England, where it was called TACS, and in Japan, where it was called MCS L1. In all mobile phone systems, a geographic region is divided up into cells, which is why the devices are sometimes called cell phones. In AMPS, the cells are typically 10 to 20 kilometers across. In digital systems, the cells are smaller. Each cell uses some set of frequencies not used by any of its neighbors. Handoffs can be done in two ways. In a soft handoff, the telephone is acquired by the new base station before the previous one signs off. In this way, there is no loss of continuity. The downside here is that the telephone needs to be able to tune to two frequencies at the same time, the old one and the new one. Channels. The AMPS system uses 832 full duplex channels, each consisting of a pair of simplex channels. There are 832 simplex transmission channels from 824 to 849 megahertz, and 832 simplex receive channels from 869 to 894 megahertz. Each of these simplex channels is 30 kilohertz wide. Thus, AMPS uses FDM to separate the channels. In the 800 megahertz band, radio waves are about 40 centimeters long and travel in straight lines. They are absorbed by trees and plants and bounce off the ground and buildings. This may lead to an echo or signal distortion, multipath fading. Call management. Each mobile telephone in AMPS has a 32-bit serial number and a 10-digit telephone number in its PROM. The telephone number is represented as a 3-digit area code in 10 bits and a 7-digit subscriber number in 24 bits. When a phone is switched on, it scans a pre-programmed list of 21 control channels to find the most powerful signal. The phone then broadcasts its 32-bit serial number and 34-bit telephone number. Like all the control information in AMPS, this packet is sent in digital form multiple times and with an error-correcting code, even though the voice channels themselves are analog. Let's now learn about Personal Communication System. Personal Communication System is a wireless phone service similar to cellular telephone service, but emphasizing personal service and extended mobility. It's sometimes referred to as digital cellular, although cellular systems can also be digital. Like cellular, PCS is for mobile users and requires a number of antennas to blanket an area of coverage. Several technologies are used for PCS in the United States, including Time Division Multiple Access, TDMA, Code Division Multiple Access, CDMA, and Global System for Mobile or GSM communication. GSM is more commonly used in Europe and elsewhere. PCS, also known as Personal Communication Network or PCN, is part of the current trend towards a future of digital communications technology that will include digital television, digital MMDS or wireless cable, digital cameras, and digital video from direct broadcast satellites or DBS. In addition to the advent of digital technology, PCS is a new entrant in the wireless telecommunications industry that differs from current analog cellular telephone networks. Different standards of transmitting phone calls. Some PCS providers use Global System for Mobile Communication, GSM, for their network systems, which has been used all over the world for many years and has established a track record of providing reliable performance. GSM technology is used to accomplish multiple accesses by assigning time slots to every user from which during that time the information must be transmitted. Other PCS providers use Code Division Multiple Access, or CDMA, for their network system, which is a new transmission standard that was invented in 1989 by Qualcomm, a company based in San Diego, California. CDMA technology is used to accomplish multiple accesses by assigning unique codes to differentiate users. Network structure of PCS. The types of equipment needed for PCS to function include a PCS handset, a base station in each cell site, and a mobile telephone switching office, or MTSO. Each base station is connected to an MTSO by a microwave link or a landline. The MTSO controls the switching between the public switched telephone network and the base station for calls between the wireline and PCS. Let's now understand the second generation cellular telephone systems. To provide higher quality, less noise-prone mobile voice communications, the second generation of cellular phone network was developed. While the first generation was designed for analog voice communication, the second generation was mainly designed for digitized voice. 4 systems are in use now: DAMPS, GSM, CDMA, and PDC. PDC is used only in Japan and is basically DAMPS modified for backward compatibility with the first generation Japanese analog system. The Digital Advanced Mobile Phone System, or DAMPS. The second generation of the AMPS system is DAMPS, and it is fully digital. It's described in International Standard IS-54 and its successor IS-136. DAMPS were carefully designed to coexist with AMPS so that both first and second generation mobile phones could operate simultaneously in the same cell. On a DAMPS mobile phone, the voice signal picked up by the microphone is digitized and compressed using a model that's more sophisticated than the delta modulation and predictive encoding schemes. With mobile telephony, there is a huge gain from doing digitization and compression in the handset, so much so that in DAMPS, 3 users can share a single frequency pair using time division multiplexing. Each frequency pair supports 25 frames per second, or of 40 milliseconds each. The control structure of DAMPS is fairly complicated. Briefly summarized, groups of 16 frames form a superframe, with certain control information present in each superframe a limited number of times. 6 main control channels are used: system configuration, real-time, and non-real-time control, paging access response, and short messages. Let's now take a look at third generation. The third generation of cellular telephony refers to a combination of technologies that provide a variety of services. Ideally, when it matures, the third generation can provide both digital data and voice communication. Using a small portable device, a person should be able to talk to anyone else in the world with a voice quality similar to that of the existing fixed telephone network. The third generation concept started in 1992 when ITU issued a blueprint called the Internet Mobile Communication 2000, or IMT 2000. The blueprint defines some criteria for third generation technology, such as voice quality comparable to that of the existing public telephone network, data rate of 144 kbps for access in a moving vehicle or car, 384 kbps for access as the user walks, pedestrian, and 2 mbps for the stationary user, office or at home. Support for packet-switched and circuit-switched data services. Let's now learn about NAMS. Narrowband Advanced Mobile Phone Service, or NAMS, is an analog mobile telephony system that was commercially introduced by Motorola in 1991. The NAMS standard, IS-88, is an evolution of the original AMPS standard. NAMPS splits an AMPS 30 kHz radio channel in 3 narrow 10 kHz channels. Digital cellular telephone. A digital cell phone, sometimes called a digital wireless phone, not only processes the sound digitally, they actually receive and transmit the audio as a digital signal via radio waves. Digital cellular is an industry term given to the new cellular technology that transmits voice information in digital form. This differs from analog cellular in that the method of transmission for voice data information is by means of digital signals. Digital mobile radio systems are often characterized by their type of access technology, TDMA or CDMA. Digital mobile telephones usually have the ability to validate their identities more securely during access than analog mobile telephones. This is made possible by a process called authentication. Authentication processes share secret data between the digital mobile phone and the cellular system. Digital technology increases system efficiency, and it does this by voice digitization, speech compression or coding, channel coding, and the use of spectrally efficient radio signal modulation. Standard voice digitization in the public switched telephone network, or PSTN, produces a data rate of 64 kilobits per second, kbps. Voice digitization and speech coding take processing time. Typically, speech frames are digitized every 20 milliseconds and inputted to the speech coder. The compression process, time alignment with the radio channel, and decompression at the receiving end all delay the voice signal. The combined delay can add up to 50 to 100 milliseconds. Here we will discuss the TCP/IP protocol details. One of the dominant second-generation standards in North America is Interim Standard 95, or IS-95. It's based on CDMA and DSSS bands and channels. IS-95 uses two bands for duplex communication. The bands can be the traditional ISM 800 MHz band or the ISM 1900 MHz band. Each band is divided into 20 channels of 1.228 MHz separated by guard bands. Forward transmission IS-95 has two different transmission techniques, one for use in the forward base to mobile direction and another for use in the reverse mobile to base direction. In the forward direction, communications between the base and all mobiles are synchronized. The base sends synchronized data to all mobiles. The signal is fed into a QPSK modulator to produce a signal of 1.228 MHz. The resulting bandwidth is shifted appropriately using FDMA. An analog channel creates 64 digital channels, of which 55 channels are traffic channels carrying digitized voice. Reverse transmission. The use of CDMA in the forward direction is possible because the pilot channel sends a continuous sequence of IS to synchronize transmission. Two data rate sets. IS-95 defines two data rate sets with 4 different rates in each set. The first set defines 9600, 4800, 2400, and 1200 BPS. In an IS-95 system, the frequency reuse factor is normally 1 because the interference from neighboring cells cannot affect CDMA or DSS transmission. Soft handoff. Every base station continuously broadcasts signals using its pilot channel. This means a mobile station can detect the pilot signal from its cell and neighboring cells. This enables a mobile station to do a soft handoff in contrast to a hard handoff. Let's now learn about the global system for mobile communications. DAMPS is widely used in the US and in modified form in Japan. Virtually everywhere else in the world, a system called GSM, Global System for Mobile Communications, is used, and it's even starting to be used in the US on a limited scale. To a first approximation, GSM is similar to DAMPS. Both are cellular systems. A GSM system has 124 pairs of simplex channels. Each simplex channel is 200 kHz wide and supports 8 separate connections on it, using time division multiplexing. Each currently active station is assigned one time slot on one channel pair. A data frame is transmitted in 547 microseconds, but a transmitter is only allowed to send one data frame every 4.615 milliseconds, since it is sharing the channel with 7 other stations. The gross rate of each channel is 270,833 BPS, divided among 8 users. This gives 33.854 kbps gross, more than double DAMPS 324 bits, 50 times per second for 16.2 kbps. Code Division Multiple Access, or CDMA. DAMPS and GSM are fairly conventional systems. They both use FDM and TDM to divide the spectrum into channels and the channels into time slots. However, there is a third kid on the block, CDMA, Code Division Multiple Access, which works completely differently. CDMA is completely different from AMPS, DAMPS, and GSM. CDMA allows each station to transmit over the entire frequency spectrum all the time. CDMA also relaxes the assumption that colliding frames are totally garbled. Instead, it assumes that multiple signals add linearly. Let's now take a look at the Personal Communications Satellite System. Satellite communication has two main components: the ground segment, which consists of fixed or mobile transmission, reception, and ancillary equipment, and the space segment, which primarily is the satellite itself. A typical satellite link involves the transmission or uplinking of a signal from an Earth station to a satellite. The satellite then receives and amplifies the signal and retransmits it back to Earth, where it is received and reamplified by Earth stations and terminals. Satellite receivers on the ground include direct-to-home DTH satellite equipment, mobile reception equipment in aircraft, satellite telephones, and handheld devices. Commercial operational satellite communication systems were developed after having working experience with a large number of experimental satellite systems launched to demonstrate the various aspects of satellite communications. Experimental satellite communication systems. For the purpose of test and evaluation of new technologies, a number of satellites have been designed and operated for technical experiments. Prominent among these experimental satellites are Applications Technology Satellite Series, ATS-1, ATS-3, ATS-5, and ATX-6 of NASA. International Satellite Systems. Currently, only a part of the world's long-distance telecom traffic is handled by different international satellite communication systems. However, for international broadcasting of television, there is no alternative to satellite communications. Examples of various international satellite systems are Intelsat, New Skies Satellite, PanAmSat, Intersputnik, Inmarsat, and Cosmos-SARSat. Domestic satellite communication systems. Satellite communications system for domestic communications is cost-effective compared to the conventional terrestrial systems under the conditions: a large country without basic terrestrial communications, population is spread over mountains, deserts, and a large number of islands, thinly populated remote areas. Some of the other countries with their own domestic satellite communication systems are United States of America, Western, SBS, etc., and India, INSAT. Military satellite system. For military communications, Army, Air Force, and Navy use both fixed and mobile satellite systems. In addition to the normal communications, military communications are also required for tactical communications from remote and inhospitable locations. Examples of military satellite communication systems are DSCS, U.S. Air Force, Skynet, UK, and NATO, and FLT SATCOM, U.S. Navy. Now in the end, let us summarize what we have learned in this lecture. The MSC contains communication controllers that adapt signals from base stations into a form that can be connected or switched between other base stations or to lines that connect to the public telephone network. The traditional telephone system, even if it someday gets multi-gigabit end-to-end fiber, will still not be able to satisfy a growing group of users, people on the go. Cellular telephony is designed to provide communications between two moving units, called mobile stations, or MSs, or between one mobile unit and one stationary unit, often called a land unit. In all mobile phone systems, a geographic region is divided up into cells, which is why the devices are sometimes called cell phones. Personal communication system is a wireless phone service similar to cellular telephone service, but emphasizing personal service and extended mobility.